Hey guys, in this video the brilliant Mr. B is going to be taking you through 15 examples of working out factors of things. Now this is a core skill that comes up lots and lots, so it is worth practicing well. There are 15 different examples here at 3 different levels and you can decide where you start. Do you want to start with the easy ones and slowly work through, or do you want to challenge yourself and start with the harder ones? If you want more practice at this, then there are loads more videos just waiting for you over on my website.
Okay, so what are factors? Multiples are related to multiplication, and the multiple of a number is that number's times table. You multiply that number to get the list of multiples. With factors, they are related to division, and we're looking for all the numbers which divide into the number we're finding the factor of. So for the first question, if we are finding the factors of 8, I'll set up my working out like this, and I want to list all the numbers which divide into 8. Now, you might be tempted to look at it and go, oh, well, I guess 4 will divide into it, 2 will divide into it, and you can just kind of pick numbers at random that'll go in. Now, the problem with this method is you're probably going to miss a few factors out. So we want to follow a system. We want a systematic method. So what do we do? Well, just try and divide it by every single number, starting with the smallest number, 1. So 8 divided by 1 is 8. So because we have a whole number answer, 1 is a factor. Now we're going to move to the next number, which is 2. 8 divided by 2 is 4. And again, we have a whole number answer, so 2 is a factor. Then we would move on to 3. 8 divided by 3, and we can fit 2 3's into 8, but we'd have a remainder 2, so it doesn't divide in evenly. So because we don't get a whole number answer, 3 is not a factor of 8. Then we move on to 4. 8 divided by 4, and 8 divided by 4 is 2. We have a whole number answer, so 4 is a factor. Moving on to 5, we can only fit 1 5 into 8 with remainder 3, so 5 is not a factor. 8 divided by 6, again 1 remained 2, so we're not getting a whole number there either. 7 will be the same, there's 1 7 and 8 and 1 left over, so 7's not a factor. And then 8 divided by 8 is 1, so that's a whole number, so 8 is a factor. Now you might have spotted a little pattern there. 8 divided by 1 is 8, and 8 divided by 8 is 1. 8 divided by 2 is 4, and 8 divided by 4 is 2. When you divide by a number and you get a whole number answer, that number's a factor, but the answer will also be a factor. Let's use this when we find the factors of 10. Let's start off the smallest number, 1. 10 divided by 1 is 10. 1 is a factor, but our answer 10 is also a factor. Now let's divide by the next number, 2. 10 divided by 2 is 5. So that's a whole number answer, so 2 is a factor, but the answer 5 is also a factor. And we can test it. 10 divided by 5 is 2, so we're getting that whole number again, so 5 is definitely a factor. Then we try dividing 10 by 3, and 10 divided by 3 is 3, remainder 1, so that's not a whole number, 3 isn't a factor, and 10 divided by 4 is 2, remainder 2, so 4 isn't a factor either. Now moving on to 5, and you might be thinking to yourself, well, I'm going to have to do 5, 6, 7, 8 and 9, this is going to take forever, but when we do 10 divided by 5, which is 2, so 5 is a factor, we already have 5 as a factor, so we're repeating ourselves. When you start to repeat yourself, you know you finish your list and you have a complete set of factors. Now moving on to 11. 11 divided by 1 is 11, so 1 and 11 are factors. 11 divided by 2 would be 5 remainder 1, so that's not a factor. 11 divided by 3 would be 3 remainder 2, so that's no good. 11 divided by 4 would be 2 remainder 3, so that's no good either. And 11 divided by 5 would be 2 remainder 1, so that's not going to work. And again, to shorten things down, you don't need to go through every single number. Once you've got through half the list, you finished 6, 7, 8, 9, 10. None of these are going to work. they're all more than 11, so you'll always get 1 and a remainder. 11 only has two factors, 1 and 11, and that makes it a prime number. Prime numbers have got two factors themselves and 1. Now looking at 9, so we'll start with dividing it by 1. 9 divided by 1 is 9. Then we'll divide by 2. 9 divided by 2 is 4.5. That's a decimal number, so it's not going to be a factor. And then 9 divided by 3 is 3. So that's a factor. Now, I know that I said that the question and the answer are both going to be factors, so you might want to write down 3 twice. However, we only need to count it once, and we also have repeated ourselves, so we know that we have finished our list. So 9, which is a square number, has got an odd number of factors. It has got 3 factors. Finally, for the easy questions, we are going to look at 36, following the same method. 36 divided by 1 is 36. And you'll notice, if you look at all the answers, 1 is a factor of all of these numbers, and every number has 1 as a factor. You can divide every number by 1, and you'll also see that every number has itself as a factor. You can always write 1 and itself as factors. 36 is an even number, so it's definitely going to have 2 as a factor, and 36 divided by 2 is 18. 36 divided by 3 would be 12. Moving on to 4. 36 divided by 4 is 9. 36 divided by 5 would be 7 remainder 1, so that won't be a factor. We don't have a whole number. And 36 divided by 6 would be 6. Like we do with 9, we're only going to write 1 6 down. And because we said that twice, whenever you repeat yourself in these, you know that you have finished your list. And again, as a square number, 36 has an odd number of factors. It has got 9 factors. You might also notice 36 has got way more factors than any of the other numbers here, and if you ever wondered yourself why circles have 360 degrees, this is the reason. 360 was chosen for circles because of the amount of factors you can get out of 360. And you see with 36 we've already got 7 factors, so imagine how many 360 has. Now for the median questions, we're going to look at something called HCF. And what HCF means is the highest common factor. And if you've watched the video on lowest common multiples already, it works in a very similar way. So we're going to go through the acronym backwards. We'll start with the F, then cover the C, and then the H. So the F means factor. I'm going to find the factors of our numbers. So for our first question, we have 12 and we have 6. So we'll find the factors of 12 and the factors of 6 to start off. So we'll follow the method we went through with the easy questions. So 12 divided by 1 is 12, both whole numbers, both factors. 12 divided by 2 is 6, both whole numbers, so they're both factors. 12 divided by 3 is 4. So they're factors. And then 12 divided by 4 is 3, but we already have those numbers, so we know that we've finished our list. You'll also notice that 12 has got 6 factors, which is quite a lot. And if you did just pick random factors off the top of your head, then you're probably going to miss a few out. So it's very, very important to start at 1 and just work your way through one number at a time. Using the same method with 6, 6 divided by 1 is 6. Whole numbers, so they're both factors, and 6 divided by 2 is. So then when we do 6 divided by 3 next, we already have 3 as a factor. We are repeating ourselves, so we have finished our list. So we found the factors. Now let's move on to the next letter, common. We are looking for numbers which are common to both lists. 1 is in both lists, that's a common number. 2 is in both lists. 3 is in both lists, and 6 is in both lists. There are 4 factors which are common to 12 and 6. Now we move on to the next letter, H for highest. We are looking for the highest number which is in both lists, the highest number that I highlighted. So 6 is the highest common factor of 12 and 6. An important mistake to mention here, which a lot of students make, is that 12 is the highest number in both lists, but 12 is not common to both lists. So don't just put 12 down, the highest number, it's got to be the highest number that is in both lists. Now for question 2, we'll repeat the method. So we find the highest common factor of 15 and 10. So let's find the factors of 15 first. So 15 divided by 1 is 15, both whole numbers, both factors. 15 divided by 2 is 7.5. That's a decimal number, so that's not a factor. It's got to be a whole number. 15 divided by 3 is 5. So 3 and 5 are both factors because of whole numbers. 15 divided by 4 is going to be 3 remainder 2, so not a whole number. And 15 divided by 5, we already have 5. We're repeating ourselves, so we've finished our list of factors for 15. Now looking at 10. 10 divided by 1 is 10. 10 divided by 2 is 5. 10 divided by 3 would be 3 remainder 1. And 10 divided by 4 would be 2 remainder 2. Then moving on to 5, we already have 5, we're repeating ourselves, so we have finished our list of factors for 10. Now we've found the factors, F, we're looking for common numbers, C, so we have 1 in both lists, and we have 5 in both lists. 1 and 5 are common to both lists. They are factors of both numbers. And now we've done C, we move on to H, highest, you want the highest number, not the highest number in both lists, but the highest highlighted number in both lists, the highest number which is in both, which would be 5. The highest common factor of 15 and 10 is 5. Question 3, we have 16 and 20. So we're going to find the factors of both numbers. 16 divided by 1 is 16. 16 divided by 2 is 8. 16 divided by 3 would be 5 remainder 1, so not a whole number, not a factor. And 16 divided by 4 is 4. We've got 2 4s there. We are repeating ourselves. We have finished the list for 16. 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 3. Well, I know that 21's in the 3 times table, so one below that's definitely not going to be there. So I know that 3 is not going to work. 20 divided by 4, well, I could halve it and halve it again for divide by 4. Half of 20 is 10 and half of 10 is 5, so 24 is 5. And then 20 divided by 5, we are repeating ourselves, we already have 5, so we have finished our list. Now we have the factors. Let's look for common numbers to both lists. They both have 1, they both have 2, they both have 4, and I can't spell it anymore, so there are 2 numbers common to both lists. Now moving on to the H for highest, we're looking for the highest number, which is common to both lists. Again, it's not 20, it's the 4. The number has to be in both lists. So the highest common factor of 16 and 20 is 4. For question 4, we have 30 and 36. Let's make a list of factors first. 30 divided by 1, 30 divided by 2 is 15. 30 divided by 3 is 10. 30 divided by 4, well, we could try halving it and halving it again. So half of 30 is 15, half of 15 is 7.5. Not a whole number, so 4 is not going to work. And 30 divided by 5 would be 6. And moving on to 6, we already have 6. We are repeating ourselves. We have finished our list. Looking at 36 now, divide by 1, divide by 2, divide by 3, divide by 4, divide by 5, and 36 divided by 5. Well, we know that anything in the 5 times table ends in a 5 or a 0, so we know that 5 won't work. And then 36 divided by 6 is 6. And because we want to write 6 down twice, we are repeating ourselves, so we have finished our list. So again, now we've done F for factors, let's do C for common. Which numbers are common to both lists? They both have 1, they both have 2 and 3. They both have 6, and I don't think I can see any more, so they have 4 numbers which are common factors. And the highest one of those numbers is 6. So the highest common factor of 30 and 36 is 6. Moving on to the final medium question, we've already found the factors of 10, so we'll reuse that for the previous question. So let's write down the factors of 9, and you might remember these from the easy questions. you can divide every number by itself and 1, and as a square number, the square root will be a factor as well, and they are all the factors of 9. And if you look at the list for 9 and list for 10, you can see there's only one number which is common to both lists, and that is 1. And 1 is a factor of every single number, so you'll always have an answer, but if numbers aren't very well matched to each other, that answer is going to be 1. Moving on to the hard questions, you'll now notice that the numbers we need to find factors of are much larger, and these numbers are going to have quite a lot of factors for us to find. Now, we could use the same method, we could write a really long list, but there are a risk of missing numbers or it taking too much time in the exam. So like we did with lowest common multiple, we will do the same thing here and move on to a different method. Now, it's actually exactly the same method you would use in lowest common multiple with one change at the end. So for question 1, we're going to take 42 and we're going to take 64, and we are going to draw prime factor trees for these numbers. Prime factor decomposition is another name for it. I want two numbers which multiply together to make 42. With even numbers, it's normally best to divide by 2 to halve it. So 42 divided by 2 would be 21, and that means 2 times 21 is 42. Then repeat the process with the numbers we've just made. So 2 is a prime number. We can't continue with the list. And for 21, we could do 3 times 7 makes 21. Then repeat the method for the 3. That's a prime number. We can't continue there. And the 7 is also a prime number. So now all the branches are complete. We have finished our tree diagram. Now let's do the tree diagram for 64. Now we could divide by 2 and have 2 times 32, but it's usually best if you can use higher numbers. And a nice little trick with square numbers like 64 is to use the square root. 8 times 8 is 64. And then because both these numbers are the same, we can use the same tree for each number, and it saves a little bit of work. Repeating the method for 8. 8 would be 2 times 4, and 4 would be 2 times 2, with 2 of course being a prime number and ending that branch. So then when we come over to the other side and look at the second 8, we can just draw exactly the same tree, and we don't need to think about it. We can just copy it. Now, if we hadn't have chosen 8 and 8, and we did do 32 and 2, we would have gotten exactly the same answers, but we would have got a much longer tree, and it would have taken up space I need for working out later on. So now, just like we did with the lowest common multiples, we're going to draw a Venn diagram with our results. So we'll have a circle representing 42 and a circle representing 64. We're going to look for numbers which are in both trees. So we have a 2 in both trees. That'll go in the overlap in the middle. Now 42 doesn't have any more 2's, but 64 has got 1, 2, 3, 4, 5 2's extra. So those 5 2's will go in the circle that only represents 64. 42 has a 3 and a 7, so these will go in the circle only representing 42. Now, when we found the lowest common multiple, we multiplied all of the numbers together, and that would get us the lowest common multiple. With the highest common factor, there's a small difference. You only multiply the numbers in the overlap. And if we take a look at the overlap, nice and easy, there is only one number in there. We have the 2 in there. So there's only one number. We don't need to multiply. That would be the answer. So the highest common factor of 42 and 64 is 2. Now, I've mentioned the method for lowest common multiple a few times here. If you're not familiar with these diagrams, then go and have a look at the prime factor tree video or have a look at the lowest common multiple video, and that will cover this method in more detail. But now, as you can see, the screen's full, so we're going to wipe the screen. I'm going to move on to question 2. We have 100 and we have 90. We're going to draw prime factor trees for both numbers. If they end in a 0, I recommend dividing by 10. So 100 divided by 10 is 10. That will give us 10 times 10 is 100. Then moving on to the 10, 2 times 5 is 10. And because they're both the same number, we can have the same tree for both. Then looking at 2 and 5, these are prime numbers. So that's the end of our tree for 100. Same method for 90. Let's divide it by 10. 90 divided by 10 is 9. And that gives us 9 times 10 is 90. So for 9, 3 times 3 is 9. And since we have 10 for a third time here, we're just going to copy down exactly the same tree. And now we know that 3 is a prime number, and we've already done the tree for 10. 2 and 5 are prime numbers. We have completed our prime factor trees. So moving on to the Venn diagram, a circle representing 100 and a circle representing 90. Let's look for numbers which are in both trees first, and they both have a 2 and they both have a 5, so those numbers go in both circles, so they'll go in the overlap in the middle. Now 90 has got 2 3s and 100 doesn't, so they'll go in 90's circle, and 100 has an extra 2 and an extra 5 that 90 doesn't have, so they'll go in 100. Now again, thinking back to previous methods, for the lowest common multiple, we would multiply all of these together, but for the highest common factor, we want the numbers in the overlap multiplied together, and you can see a 2 and a 5 in there. So the highest common factor, the numbers in the overlap multiplied together, 2 times 5, which gives us 10. The highest common factor of 190 is 10. Moving on to question 3, we have the highest common factor of 64 and 90. We're going to do factor trees for both. Now, we did these in previous questions. We just copy the factor trees from those. So 8 times 8 was 64, with 2 and 4 making 8, and 2 and 2 making 4. Repeating that for the second 8. And for 90, we had 9 times 10. 9 was 3 times 3, and 10 was 2 times 5. Let's highlight all the prime numbers. So, don't do working out twice if you don't need to. We did these in previous questions. We can reuse them. Then we're going to move on to our Venn diagrams. So we'll have a circle for 64 and a circle for 90. Let's look at the overlap first. We want prime factors which are in both trees, and we can see they both have a 2, and there is nothing else in both trees. Now, I could finish the diagram off here, but what we're looking for is we're multiplying all the numbers in the middle of the diagram together, and we already have all the numbers in the middle of the diagram. So why do we need to do the rest of this? The highest common factor, all the numbers in the overlap multiplied together. There's only one number in there, and it's a 2. So the highest common factor of 64 and 90 is 2. Now, I do want to go back and finish the diagram. I can't leave something half done. So we've got the 2's in here, and we've got the 3's and the 5's. But I'm just going to try and show you that while it's good to be thorough, and we can use this method for both highest common factor and lowest common multiple, when you get confident, then you can start to skip parts of the method, and you can even skip the Venn diagram altogether and just look at the numbers which are repeated in the tree diagrams. Moving on to question 4, we have the highest common factor of 80 and 81. So let's do our tree diagrams. So 80 ends in a 0, so let's do 8 times 10. We always know that 10 will be a factor if there's a 0 on the end. Repeating the method for 8, we have 2 times 4, and 10 would give us 2 times 5. Let's look for prime numbers. So we have the 2 and we have the 5. Now 4 isn't a prime number, so I have to continue the tree from there, and 4 would be 2 times 2. Now we finish the tree for 80. Let's have a look at 81. It's a square number, so it's always a good idea to use a square root for it. 9 times 9 is 81. And then 9 would be 3 times 3, and 3 would be a prime number. So that's the end of that tree as well. Now let's move on to our Venn diagram. So we'll have a circle representing 80 and a circle representing 81. We're going to look for numbers which are in both, and actually we have no numbers which are in both lists. For our Venn diagrams, 81 has got 4 3's and 80 has got no 3's, so these go in 81 circle. 80 has got 3 2's and 81 has got no 2's, so these will go in 80 circle, and there's an extra 2, and we have the 5 as well. When we're finding the highest common factor, I said that you multiply all the numbers in the middle together, and there is nothing there. So what do we do? Does that mean that 80 and 81 have no common factors? Well, if you think back, we said that every single number has got one and itself as factors. So 80 has 1 as a factor, and 81 has 1 as a factor. So the highest common factor must be 1. And the reason why 1 is not showing up in our diagram is because 1 is not a prime number, so it's not going to appear here. But we do know that every number has 1 as a factor, so the highest common factor is 1. Moving on to our final question, we have 90 and 72. Prime factors of 90, we've done this already. 9 times 10 is 90, 3 times 3 is 90, and 2 times 5 is 10. So we have our prime numbers, and we've finished our tree. 72 is a new number for us to use, so let's break it down. Now, with 72, I can see it's 8 away from 80, so it must be in the 8 times table. And if 8 times 10 is 80, then 8 times 9 must be 72. Repeating the method for 8, 4 times 2 is 8, and for 9, 3 times 3 is 9. Repeating the method for these numbers, 4 would be 2 times 2, and then everything else is a prime number, so those trees are going to stop where they are. Now moving on to the Venn diagram, having a circle representing 90 and a circle representing 72. Let's look for prime numbers which are in both lists too. So there is a 2 in both lists and there is a 3 in both lists. See any others? They both have a second 3, so that will go in there as well. 90 has a 5 and 72 doesn't, so that will go in 90 circle. And 72 has 2 more 2s, which 90 doesn't, so they will go in 72 circle. We are looking at the numbers in the overlap, and we have 2 and 2 3s. So the highest common factor is going to be all those numbers in the overlap multiplied together. 2 times 3 times 3. So one step at a time. 2 times 3 is 6, and 6 times 3 is 18. So the highest common factor of 90 and 72 is 18.